Determination of the pi terms. So how do we find the pi terms? So I'm going to explain one technique, and next video I will explain a different technique. So there are 8 steps involved in this technique. First of all, you have to list all the parameters, all the variables that are involved in the problem. Express each variables in terms of a basic dimension. So you have to do basically a list. So velocity, force, and so forth, and then make a table with the dimensions. So for example, length, t to the negative 1, force is mass times acceleration, and so forth. So you have to determine the number of pi variables. Remember, the number of pi variables is k minus r. Then you have to select the number of repeated variables. So you have to choose some variables that are going to be like the base in the formation of the pi numbers. So these in general are going to be r. So you have to select r repeating variables, and then you have to form a pi term by combining the repeating variables with one of the remaining variables. So you from the 5 in this case that you have, so you choose 3 variables, and the 2 that are left, so you are going to combine these 3 variables with the other 2 variables, so you form the 2 pi terms. Okay, so you combine the repeated variables with one of the others, and you form a pi term. So the way of doing it is like a combination that will result in a dimensionless number. So after you do for each single variable, so every single that is left, in this case k minus r is equal to 2, so for the 2, so you have to check the result in pi terms, make sure they are dimensionless, you didn't make a mistake, and then final step, you have to find the new relationship. So remember, you start from something like, in this case we have the force, let's write it this way, equal to a function of velocity, whatever, and then you're going to end up with a different relationship, pi 1, which is equal to phi of pi 2, and so forth, the number of pi variables that you have. So this is going to be a different relationship. The important thing is try to maintain the same form. If force was in the dependent variable, try that the pi variable will have the force in there, the first pi variable, the one corresponding to the dependent variable. Okay, let's see it with an example. So it is easier when you do it with an example. So suppose that you have a physical phenomenon in which force is a function of length, velocity, density, and viscosity. It's the example that we have been working on. And so we have our 5 variables, 1, 2, 3, 4, 5 variables. So we list them, so that's the first step, we list them, and basic dimensions, so we compose the table. So for the force, we have the dimensions, for the length, velocity, density, and viscosity. So these are the dimensions. And then we count, we have 5 variables, and then we are going to count how many basic reference dimensions do we have. So we have mass, we have length, and we have time. So time, and time. So we don't have anything else. So we have 3. So therefore the number of pi variables, it is 5 minus 3 equal to 2. So we are going to have 3. And r is equal to 3. And also we are going to select 3 variables that we are going to combine to form the other ones. Okay, which one do we select? Okay, first of all, we do not select f, which is the dependent variable. So we are left with these ones. So from this one, what we choose? So the idea is that they do not form a dimensionless variable. So, and if we combine them, uh, we will need an additional variable to form the dimensionless variable. So we can, it's like trying to be like the most decimal in variables. So we choose, for example, in this case, L has dimension of length. Okay, velocity, if we choose velocity, has dimension of t. If we combine these two, they are not going to be cancelled because there is no time in the first one. And if we select density, density has mass. So if we combine them, we cannot make a dimensional variable because mass is only in one of those and time is only in one of those. So it's going to be impossible. Any combination, and when I say any combination, so we have we multiply L to some power, V to some power, and rho to some power. So that's the combination. So we cannot find any exponent in such a way that the mass and the time is going to cancel. So that's the idea, the most decimal ones. So, okay, let's select length, velocity, and density. So now we are going to combine with the remaining two. The remaining two, let me do it in here in red. The remaining two are F and mu. So we have to combine L, V, rho with F and then with mu. So in the first case, we combine it with F. Okay, so we have length to the power of A, velocity to the power of B, rho to the power of C, and force, we have force to the power of 1. So the one that the new one, it is going to be always to the power of 1. And so this is equal in terms of dimensions. So the dimensions of this is L, the dimensions of length of L, which is length, A, L to the A, the dimensions of velocity to the B, the dimensions of density to the C, and the dimensions of F has to be equal to MLT to the 0. So that means dimensionless. So we have to find A, B, and C such as the dimensions are cancelled. So we have three variables, A, B, and C, so we need three equations. So how do we obtain the three equations? So we are going to obtain the three equations by selecting the three different dimensions that we have: mass, length, and time. So for mass, so if we have mass, so what we have is mass. In this case, let me clear this a little bit. We have mass, and we have mass, and we have mass. So we have that m to the c multiplied by m, the second one, and that should be equal to m to the 0. So this is the first equation. So second equation, length, let me change to blue. So we have length so we have length to the A, L to the A. The second one is length to the B. The third one is length to the minus 3c. The exponents multiply, and multiply by L should be equal to L to the 0. And the final one will be time. So for time, so we have time to the negative b, so t to the minus b, and we have t to the negative 2, and that should be equal to t to the 0.